Okay, so this is question number 7. Now we have been given a pattern, and I would start off by actually drawing the pattern. Now we have, let me give the title of this question. The diagram shows three shapes in sequence. Okay, so the entire question is based on this sequence. Okay, so this is what they have given us. So you have black circles and white circles. So they are mentioning it in the question. Okay, so right, so this is how it looks. So you have the black circles on the top and the white circles are drawn below. So what we have to do is we have to study the pattern. Now this is given. Now we need to draw the next one. So how are we going to draw the next one? Now it's already given in the question that figure 1, figure 2, figure 3. Okay, but we have to draw figure 4. So unless we get to know the pattern for figure 1, figure 2 and figure 3, we wouldn't be able to arrive at the last figure. Okay, so I'm going to show you how to figure it out. Now clearly you can see here you have this triangle. Now you will have to have this as your base, the 4 circles on the top. So what I'm going to do is I'm going to draw the circles 1, 2, 3, and then there is this top one, and then 1, 2, 3, 1, 2, 3. So now the next figure, what you will have to do is you will have to add one circle extra. Okay, so add one circle extra above this, one circle extra above this, one circle extra above this. So you got that top triangle. Now you follow it up with the circles below. Okay, so you got 1, 2, 3, right? And 1, 2, you got 3 circles like this. Now if you were to observe the first figure, you add this 3 rows of circles. Even in the second figure you got 3 rows of the circles, but there is one increment. Now that increment is an addition of one extra row. So that extra row goes over here, 1, 2, 3, 4 and 5. Okay, so this is going to be my figure 2. So this is my figure 1. So clearly, since I have given you this pattern, you would easily figure or I would say you would easily find out the third one. So how the third one goes. So draw this second architecture. So let me draw the top triangle. Okay, so these are all black circles. Okay, so let me draw the top triangle 1, 2, 3, 4 and 5, and then above this you got 1, 2, 3, and then you got the top triangle. Okay, now for the next figure, what I mentioned to you in the second figure, you add a circle like this, 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 add a circle like this. Okay, so you have done that. Now there is a addition of a circle here, addition of a circle here, so that the triangle is created. So all of these are all black circles. Okay, then comes the white circles. So you stack them up. So for this you got 1, 2, 3, 4. For the next one you need to have 5. So 1 is already there, 2, 3, 4 and 5. Okay, so 1, 2, 3, 4. So just add the circles up. So these are all white circles, you don't have to shade them up. Actually these are all given in the exam, but I'm just drawing it so that we can get the fourth figure out. So this is how the figure 3 looks. So now let's go and draw the figure 4. This is required. So draw the top triangle first. So it's going to be 1, 2, 3, 1, 2, 3 and 4 there. Okay, so this is the topmost triangle, so I'm just going to add the shapes here. And okay, so and you have this. So these are all black circles. Okay, now what we need to do is we need to add 1 year, 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 and the top. Okay, so now the triangle is cut. So now what we need to do is we need to add a circle here, a circle here. So this is a black circle. So the triangle is created. Now you stack them up with circles. So over here it's 1, 2, 3, 4, 5. So over here it's going to be 6. Right, already one row is there. So 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. Okay, so 1, 2, 3, 4, 5. So you just circle them up, or I would say add the circles. Okay, so all these are black circles, and these are all white circles. Okay, so this is my figure 4. So that completes the first part for this question. Okay, so now we move on to the next part. Okay, so this is the next part, part B. Now I mentioned to you as circles. Now they are mentioning it as counters. Okay, so just for simplicity's sake, I have mentioned the word circle here because they look circles. Okay, having mentioned that, let me write the second part of the question. The number of white counters W, the number of black counters B, and the number of total counters D that form the pattern. Are given in the table. Okay, study the pattern and complete the table. So I'm going to be drawing the table and complete it. Okay, so this is shape number. This is number of white counters, number of black counters. This is total number of counters. This is T, B, W, and this is S. So 1, 2, 3, 4 is given. or I would say 4 is asked. We know 1, 2, 3. So let me just complete the table. And then somewhere we need to fill this up. And then finally we need to fill this up. Now over here this is given as 144, 420, and this one can be found out. In fact, they have given this up. Okay, but we need to find this, and find this, find this, and ensure that we are producing this 3n squared positive 5n positive 2. Now this is a quadratic equation. Now you can clearly see how the application of quadratic equation is actually seen here. Okay, so let me fill up these values. So this is what is given in the question. It's given in the question 1 positive 1 of or times 2 of 1 positive 1, and that value is 6. Next one, 2 positive 1 of 2 times of 2 positive 1 is equal to 15. And for third one, 3 positive 1 of 2 times of 3 positive 1 is equal to 28. And for this, 1 positive 1 whole squared is 4. 2 positive 1 the whole squared is equal to 9. 3 positive 1 the whole squared is equal to 16. So we have to get this, and this is given as 10, 24, 44. Okay. Alright, now let me go and show you this pattern. Now what you see here, 1, 2, 3. So that means there is an increment of 1 unit. And if you were to see the adjacent column, when the shape is 1, this is 1. Shape is 2, this is 2. Shape is 3, this is 3. So this count is actually incrementing in terms of 1 unit. So that means we will have to have, for the white column, the first unit is going to be n. Next you see 1, 1, 1. There is no change. So that's a constant being added. Then you open the parenthesis. You see here 2, 2, 2. So there's no change. That's a constant. And then you open the parenthesis. You see this increment 1, 2, 3. So that means there is an n that is coming there. Plus you see here 1, 1, 1. So that's again a constant. So this is going to be the standard pattern. Now we need to produce 45 for 4. So that means for that is a check. For n is equal to 4, what happens here? 4 positive 1 times 2 times of 4 positive 1. This is 5 times 2 times 4 is 8. 8 positive 1. This is 5 times of 8 positive 1 is 9. 9 times 5 is 45. So this formula is holding good. Okay, fair enough. So let me go to the next one. For B, you see here 1, 2, 3. So that means B is equal to, that's going to be n, followed by 1, 1, 1. There's no change. And what do you see here? The index is 2, 2, 2. So 2 there. Now we took the value n is equal to 4. Substitute the same value, n is equal to 4 here. So it's going to be 4 positive 1 the whole square, which is 5 squared, which is nothing but 25. So this is going to be 25. Now you add 45 plus 25. So what do you get? T. You write the value. You write the expression here. T is equal to 45 plus 25. So that's going to be 70. So go up over here and you write the value 70. Okay, fair enough. Alright, so now the most important question is, what will produce the value of 144? Okay, we need to find that n value here. So we are asked to get this, okay, and this. So how are we going to do that? Now that can easily be got. How? Now clearly we know b is equal to n positive 1 the whole square. So write that out, because this is the last value, or I would say the nth term. So this is going to be n positive 1 the whole squared. And what is this? This is going to be n positive 1 times 2 times n positive 1. Okay. Now you see here, this value is already given. I'm going to write this out. So given 144. So this means n positive 1 the whole squared is equal to 144. Okay. This is for some n. We don't know the value for what n, but for some n. Okay. So the pattern takes the value 144. Now we take square root on both sides. So taking square root on both sides, what do we get? For this, the square root and the square gets cancelled. You get n positive 1. But square root of 144 is 12. So this means n is equal to 12. You push this one to the other side, you get negative 1. So n is equal to 11. So this shape, for this shape is actually obtained for figure 11. Okay. Now moving on, we need to get this value, right? So all we need to do is substitute the value 11 for w. So w is equal to 11 positive 1 times 2 times 11 positive 1. 11 added with 1 is 12. 2 times 11 is 22 added with 1. This is 12 times 22 plus 1 is 23. So we need to multiply 23 with 12. So what do you get? 2 times 3 is 6, 2 times 2 is 4, 3 times 1 is 3, 2 times 1 is 2. This is 6, 7 and 2. 276 is the value. Okay. So substitute the value 276. So we have got all the information. So now the all important information is, if we expand this and add to this expansion, we need to produce this. So that is the final check. So let me show you that. So what is required? T is actually n positive 1 times 2n positive 1 added with n positive 1 the whole squared. So this t is given as 3n squared positive 5n positive 2. Okay, so we need to produce that. So how are we going to produce it? N into 2n is 2n squared, n into 1 is n, 1 into 2n is 2n, 1 into 1 is 1. A plus b the whole squared. So what is a plus b the whole squared? Is a squared plus 2ab plus b squared. So this is n squared plus 2n plus 1. So expand this. 2n squared plus n squared is 3n squared. N positive 2n, 3n with 2n is 5n. 1 added with 1 is 2. So what do you have here? This is left hand side. What do you have here? Right hand side. So this means left hand side is equal to right hand side. Hence proved. Okay, so this is the important step that you have to conclude to show the examiner that you have a firm grip on the concept. So let's move on. Now this is the final part of the question. So let me write the question down. The expression for the number of counters t is equal to w plus p in shape s is given by t is equal to 8 times s squared plus b times s plus 2, where a and b are positive integers. By substituting suitable values for s, show that the total number of counters in shape 1 and shape 3 in terms of A and B is represented by the equation A positive B is equal to 8 and 3a positive b is equal to 14 respectively. Okay, so you read the question, understand it, and let's do it. Okay, so what we are given that t is equal to a squared positive b is positive 2. So this is the solution. But we know something else also. We know that, see, what is that we know? This is also t. Okay, you also know that t is equal to 3n squared positive 5n positive 2. I take this as 1, I take this as 2. Comparing 1 and 2, we get, so what do we get? In place of a, you have 3. In place of b, you have 5. So box the result. That is the first part. Okay, so now we will have to show that a positive b is equal to 8. Okay, that is imperative, right? But how are we going to show that? That's also a very important question. Okay, so since we have got a is equal to 3 and b is equal to 5, hence 1 can be rewritten as t is equal to 3 times s squared positive 5 times s positive 2. Okay, this is the next step. Now they are asking us to show for the first figure, for shape 1, this is true. Okay, so you write here, for s is equal to 1, what we need to do? This is equal to 3 times of 1 square positive 5 times of 1 positive 2. Okay, so this is going to be 3 added with 5 added with 2. So we're getting t is equal to 10 here for s is equal to 1. Okay, that is not the end of the question. So we need to actually have one more step. So what is that one more step? So study this. S is equal to 1, t is equal to 10. So I'm going to write this down. For s is equal to 1, we have t is equal to 10. Hence 1 can be rewritten. So what is 1? 1 is nothing but t is equal to 8 times of s squared positive b times of s positive, what is that we got? Positive 2. Okay, so this becomes, what does this become? So substitute the value, t is equal to 10. Just retain the value for a, so as it is. So a goes there as it is. A and s is equal to 1, so it's going to be 1 squared b times of s is equal to 1 positive 2. So this is going to be a positive b positive 2 is equal to 10. Move this to the other side and rewrite it as a positive b is equal to 10 negative 2, which is nothing but a positive b is equal to 8. So this is what they are asking us to show. So you see that? Show that a positive b is equal to 8. Okay, hence proved. Now that is not the end. So now you write it like this. Now for s is equal to 3, we need to know the value of t. Okay, for s is equal to 3, so use this. Okay, t is nothing but 3 times of, that's going to be s squared positive 5 times of s positive 2, and s is equal to 3, so 3 times of 3 squared positive 5 times of 3 positive 2. 9 3s are 27, 3 5s are 15 positive 2. So this is going to be 32, 42, 44. So t is equal to 44. So for s is equal to 3 and t is equal to 44, we have t is equal to a times s squared b times s positive 2 becomes 44 is equal to a times s is equal to 3, b times s is equal to 3 positive 2. 44 is equal to 9a positive 3b positive 2. Okay, so this is what we have. Now you take this 2 to the other end, so it's 44 negative 2 is equal to 9a positive 3b. This becomes 42 is equal to 9a positive 3b. Now we can divide by 3 throughout. So by 3 by 3 by 3. So this is going to be rewritten as 3a positive b is equal to 3 divides here once and you carry 1 there and it's 4. So 14. Okay. So what is this? This is exactly what we asked for. Nice. Proved. Okay, so that is the end of this particular question. And you need to practice. Without practice, it's not possible to do this. So if you can see these questions, all these questions require detailed working. And to achieve that, all it takes is consistent practice.